Alright, so now we're on to example 12, and for this example, we're going to be using a 3/4 inch end mill, and we're going to be profiling this step here on the side of this block. So let's go ahead and get our tools and our stock geometry set up. So I'm going to edit this program and save it as example 12. And next thing I'm going to do is I'm going to go to my part setup, more, stock geometry, and change my stock geometry. It's 2.5 by 3.8, and it is a 1-inch thick block. Now I'm going to go to my tool setup, and I'm going to create my 3/4 inch end mill. I'm going to call it tool 66. I'm going to make it an end mill, and it is 0.75 in diameter. I turn my coolant on and set some speeds and feeds. Alright, so now we have our geometry set up and our tool set up. Let's go ahead and start our program. I'm going to go to my program review. Since this is a copy of example 11 that we just did, I'm going to go ahead and delete this block from last time. Alright, so now we have no blocks in our program. So I'm going to click on the end of program. It takes me to the new block screen. I'm going to go to milling and lines and arcs. Okay, so first thing we're going to do is we can see our part 0. They call it out here from the top left corner. I'm just going to program it from the bottom left. You can program it for wherever you prefer. I always prefer the bottom left corner. It makes the geometry always positive. So let's go ahead and we're going to start out our end mill up here at the top right corner. That way we can do a cutter comp left. So on your CNC machines, you're always going to be doing climb cutting, which is where the tool is on the left side of the cut in the direction of motion. So our tool is up here, and we're going to plunge out into space. So we don't want to plunge at 3.8 on the part. We want to plunge up in space here. That way we have clearance as we plunge. We're not plunging directly onto our material. So we know our X is going to be 2.25, and our Y is going to be 3.8, and then we're going to add at least half of our cutter diameter, which is 0.375. Then we'll go a little bit higher than that, so let's just say 4.25. And that gives us plenty of clearance so that when we plunge, we'll be clear of our stock. Then we'll start our Z above the part, and then go down to our depth of 1/2 inch. We'll pick our tool 66. And so in the previous example, we used milling type on. This time we're going to do milling type left because we need cutter comp. Because we're going to program our geometry, and we need the machine to auto-compensate the tool path so that our end mill stays on the side of our geometry. Otherwise, our tool would run directly on top of this geometry and be incorrect. And we'll throw a peck in there. And anytime you have a peck on a finished surface, you'll want to add a finishing pass. And basically what that will do is, as it steps down, at the very end, it'll rerun it at full depth and take a skim cut. And that will remove steps in the side of the part, because as we peck, it's going to leave little scallops on the edge of our finished surface right here. This whole edge would have steps in it. So now we got that taken care of. We'll go ahead and go to our next segment. We'll do a line. And so for this next segment, we know our X point. That's this point right here. And we don't know our Y dimension. We could do the trigonometry to figure out where it's at. However, the software, as long as we give it enough information, will auto-calculate that value for us. So let's go ahead and program our X value, and we'll leave our Y value blank. So our X value is still at 2.25. And now, when we leave this value blank, make sure there's nothing in the field. Don't type in 0, because 0 is not nothing. 0 is a value. So make sure you leave that field blank completely. Any other information we know? We don't know the length of that line. We do know the angle is negative 90 degrees. So we can put negative 90 in there. If we go to next segment, we can do another line. Now this is to this point down here. So this time we don't know our x, so we can leave our x blank. But we do know our y. Our y is going to be our 3.8 minus the dimension called out here, 3.688. And that gives us 0.112 for our y dimension. Then we also know our length, as they call out here from the side, they call out 0.848 is the length of that line. And we know the angle, they call out 45 degrees. So we know the 3 o'clock position is always 0 on our degrees. So if we go negative 90, it's straight up and down, then we got to go another 40 degrees to this angle. So it's going to be negative 90 plus negative 45. So that gives us negative 135. If we go to our next segment, we can finish up with a line. So this line is going to keep the same y value and then end in x off the side of our part. And so again, we want to clear our part. We don't want to stop on our stock. So our x value, we want to go off the side of our part. So we're going to go negative 0.375, so that's half of our cutter diameter. Then we'll go a little bit past that, so we'll just say negative 0.45. So we know that's clear enough to where we'll be off the edge of the part. And we want to maintain the same y value. So now let's go ahead and draw this, see what we get. So that we can see our profile there, and our steps and our pecs. And if we zoom out, we can see that we plunged out here, ran around, and we finished out here. You can see these little curvy moves. If we go back to our segment 0 of this block, there's this enable blend moves. So that's what those little curly cues are. They're blending into our geometry. We can turn that off since we're out in space. We don't need to blend into anything. So if we draw it again, now those little curly cues are gone. And that should be it. We can go ahead and save this file. That's it for this example.